Hey everyone, so today we're going to talk about a type of problem that a lot of students have seemed to have trouble with, and it's just confidence intervals. So first, it's kind of important to know what the purpose of a confidence interval is and why one might be interested in creating one, as opposed to doing a lot of the basic statistics calculations that we'll talk about leading up to this point. So the thing about a confidence interval, it roots in one of the main aspects that I'll talk about time and time again that's important in statistics, where we're going to take a sample out of a population so we can make inferences about that population based on the sample. So in the sample, we've talked about how there's X bar, where it's just the mean, the average value, whatever it is we're wondering about, of the sample. We can do a proportion in that sample, where it's a part out of a whole, some aspect we're interested in over the total number we sampled, and that gives you some percentage that you're interested in the sample. So instead of us just being able to say that the mean value of the sample, and I'm going to use this example over and over again, but it's going to be the height of students at my university. If I want to know that exact number, I can tell you what the mean of my sample is, and that's fine, and that should be somewhat representative of what the population as a whole should say about, what the sample says about the population as a whole. But it would be kind of useful at the same time if I could tell you with a certain percent confidence a range of values that the true value of the sample might fall into. So for instance, when I say a confidence interval, it is literally an interval. It contains a lower bound and an upper bound. So this is a lower confidence limit and an upper confidence limit, thus creating a range of values in an interval. So at some percent confidence, so I could tell you with 90% confidence or 95 or 99% confidence that the true mean, or it could be a proportion, whatever the case is, but in this situation when we're dealing with the mean height of the students, we could talk about this range of values is going to contain, at a certain level of confidence, the mean height of students at my university based on the sample, applying that to the population. So really, to find the confidence interval, to actually calculate it, it's simply going to be another formula that we need to plug into. So going back to that other video where you have to know what each variable stands for, where n is the number in the sample, x bar is the mean of the sample, that becomes very important here. And if you have that down and you have this formula down, it becomes incredibly simple to solve these confidence interval problems. So the standard formula for the confidence interval is going to be your point estimate, and the reason I'm giving you the standard formula first is because depending on what type of problem you have, whether or not it's a mean-based problem or a proportion-based problem, is going to affect the way you have to plug into the formula. So if you can keep this in mind, this is very widely applicable to a lot of different situations. You just have to know kind of what to plug and play. So the point estimate plus and minus. So when I say plus and minus right here, you're going to do this formula, but in one instance of it, you're going to just do the minus portion of it. In the other instance, you're just going to do the plus portion of it. Thus, the minus portion will create your lower confidence level, and the plus portion will create your upper confidence level. So we'll get a little bit more into that later, but it's plus and minus the z multiple, and the way you find that multiple is simply these rules of thumb right here. So depending on what professor you have, you might just be able to memorize these numbers and just plug in 1.64, 1.96, 2.58 into the multiple based on what confidence level they tell you about. But for some problems and for some professors, they want you to be really specific with exactly what the multiple is. So for instance, if you have to use Excel to find those numbers, we'll cover that in a later video, how you would find that multiple, because these are all rounded values. I can't remember the exact value of 1.64, but it's many, many decimal places down along the line. So depending on how precise your professor wants you to be, will depend on whether or not you can just memorize these rounded numbers or you actually have to calculate it yourself. So just keep that in mind. But apart from that, if they tell you we want a 90% confidence interval, just put in 1.64. If we want a 95% confidence interval, 1.96, so on and so forth. So point estimate plus and minus the multiple times the standard error. And the reason I say standard error and I don't just tell you how to find standard error is that, again, to find that, it depends on what type of problem you have, a mean or a proportion-based problem. So we'll go over that in just a moment. But one more thing before we do that is that the multiple times the standard error, just this portion right here, is known as the margin of error. So if you get a problem and it says, what is the margin of error given all these values, and you're used to running confidence intervals over and over again, don't get too ahead of yourself. All you have to do is find out what the multiple is based on the 90, 95, or 99%, and then multiply by the standard error, which is going to depend on exactly what type of problem you have. So kind of leading into that, the two main problems we'll talk about are the mean-based problems and the proportion-based problems. So the mean-based, that coincides with the example I always use, which is the mean height of students at my university. It's a mean value, it's an average number that I'm looking at right here. Thus, when we're plugging into the standard formula for a mean-based problem, The point estimate is just going to be the mean, your x bar. And you do plus and minus your z multiple, which is going to be based on the 90, 95, or 99%, times S is the standard deviation that we talked about in the sample, so that should be given to you. You might have to calculate that, but odds are it'll be given to you if they're asking for a confidence interval. And you divide that by the square root of n, which is the number in the sample. And if you just plug all of those numbers in, you go about the problem to do the lower confidence limit first. So how we would do that is simply going to be x bar minus z times s divided by square root of n. And keep in mind your order of operations, so do this part first. Find that margin of error, calculate it, then subtract it from x bar, and that's going to equal your lower confidence limit. And then likewise, when we're doing the upper confidence limit, we're going to do the plus portion of it. And again, keep in mind that order of operations. And that's going to give you your upper confidence limit, and your overall answer is going to be the lower confidence limit first, comma, the upper confidence limit, thus creating that range of intervals that you're interested in. The only other thing we really need to go over for just an overview of confidence intervals is the proportion-based problems. So just know that F, that is going to be your sample proportion. So you take the sample, we're wondering about what percent of students are above 5'8". The part out of the whole, we get that value between 0 and 1, whatever that proportion is, that is your F. It is the sample proportion, and then you do the plus and minus. It's going to be the same logic as this to do the lower confidence limit and the upper confidence limit. The Z times, and see how this is much different than S divided by square root of n, right? That's because this is how you calculate the standard error for a proportion-based problem. So that's where it becomes really important to keep in mind that standard formula versus the actual characteristics of the problem that you have at the time. So be very careful to look at what type of information you have. If they're giving you mean values, average values, it's going to be a mean-based problem. Do it by this formula. If it's a part out of a whole and they're wondering about a percent of something, it's going to be a proportion-based problem. Do it by this formula. Now, this P right here, one thing I want to point out, some professors are going to use P in place of pi for the population proportion. I'm not really sure what that's based off of, but the main point is that these are going to be the population proportion-based values that you plug in right here. So whether it's pi, whether it's p, plug that number in, not f. So do your population proportion there. You know, p times 1 minus p, divide that by n, square root the whole thing. Don't forget to square root. I see that happen all the time. And you go about it the same way you did right here. Do it for the minus side, do it for the plus side, create your interval, and you're good to go. So I hope that gives you a good overview of confidence intervals, and we'll go into some examples and a little bit more nitty-gritty detail on that in the next video.